Welcome back to another exciting chemistry lesson. In this lesson, we are going to learn about solids, and we are going to look at different types of solids. Well, what is a solid? Well, solid substance consists of atoms or molecules that are packed tightly together, and therefore they have a fixed location. That means they don't move around. Now, it is either amorphous or crystalline. And if you look at the picture, amorphous solid does not have a structure, and it's the very disorder where crystalline, you have this kind of structure arrangement. In most cases, is a three-dimensional arrangement. Before we look at different solid, we need to understand the term electrical conductivity, specifically conductivity. Now, conductivity measures how well a substance transmits, or in other words, transfer electric current. Now, think about it. In order to transfer, we need to have some kind of movement, right? When we look at conductivity, we're looking in terms of ions and electron. In order to be a good conductor, the ions or the electron in the substance need to be able to move freely. So in order to conduct electricity, the ions or the electron in the substance need to be able to move. So in this case, look at this example here. We have ethanol in water and we have sodium chloride. Notice sodium chloride is dissolved, so you have this conductivity of flow of current, which allows you to turn the light bulb. Now, that is the definition of conductivity. And when we look at different type of solid, we are going to determine if it's going to be a good conductor or not. The first type of solid we are going to look at is ionic solid. Now, ionic solid are basically coming from the term ionic bond because ionic solid are made from ionic bond, which consists of a 3D arrangement, a crystalline 3D arrangement of alternating, that's a key word, alternating cations and anions. Well, cation is a positive charge, anion is a negative charge. Remember we talking about opposite charges attract? That's what happened here in an ionic solid. So in this case, we have this type of a specific attraction called the Coulombic attraction. Basically, opposite charges attract. And if we look at the structure, think of the term alternating. We have negative, and positive. And going this way as well, negative, and positive. So be careful with that, right? Here's a better representation of alternating cations and anions. And here we have different color code as well. Now, another features of ionic solids is they are very brittle, So if you smash it, it will break into little pieces, And the reason behind this, if you smash it, it's going to slide down the charges, So if it's just slide down a little bit, it will force, again, opposite charges. But if we hit it really hard, what happens when the negative and negative get together? They would repel. The same thing with the positive. And that's why when you smash it, it breaks into small pieces. Hence, we have the term brittles right there. So ionic solid, like table salt, are very brittle. Smash it, it will break into little pieces. Well, one thing we have to realize, again, if we look at this, the ions are pretty much stay in one place. So it's fixed in a place, So therefore, it is non-conductive. It's not going to conduct electricity. Because of the strong Coulombic attraction between the opposite charges, we have ionic solid have a very high melting point and boiling point. Of course, like any substance, we can actually add enough heat to energize it, to increase the kinetic energy so that it become molten. So we can actually melt it. When it is molten form, it is actually now freely moved. So when it's freely moved, it is now able to conduct electricity. And if it's not molten, we can actually dissolve in a solvent. That's happened with table salt. When we dissolve table salt in water, it is now conduct electricity. So there are two ways ionic compound can conduct electricity. One is molten, the other one is dissolved. So therefore, the ions are freely allowed to move. Now let's go down and look at another type of solid, which is metals. We all seen metals, and metals are formed from metallic bond. Here is a diagram to illustrate the structure of metallic substance. And what we have here is the nuclei, are positive charges, are stationary. Stationary basically is fixed in one location. But the valence electron, the nuclei, are moved freely, Okay, they are allowed to move freely in the sea of electron. Think of the word sea like the ocean of electrons. So electron allowed to move anywhere in the substance. What does that tell you? Well, of course, it is very good as a conductor because electrons are freely move anywhere. Okay, and that's the reason why metals like copper, gold are very good conductors. Another characteristic of metals is that it is malleable and ductile. Malleable, think of the term shape. We can hammer any metal pieces into shape. Think of all the beautiful statue we have. Think of this microphone right here. We have to hammer into shape. We can mold into this shape. And for ductile, think of wires, right? Basically, we can pull the metal into a string of wire, which allow to make electronic like this one right here. Like your computer or your electronic, all those possible because of the properties of metals. And the reason behind this is the unique structure of metals where we have a very stationary solid surrounded by the sea of electron. Now, metals can also bond with another metals to form alloys. So alloy is a mixture of different metals. There are two types of alloys. Interstitial alloy, basically when we have two types of metals that have very different radii. Because the other one, look at the other one, substitutional. Think of the word substitute. If we look at substitute, it has a very similar, right? So in this case, substitute alloy between two atoms of metals that have similar radii. So in this case, different radii, similar radii. To look at an example in this case, this right here would be what? See how the radii are about the same? So this right here is substitutional. And right here, look at the radii. This one's small, this one is large, and this one is interstitial right there. So when you look at the picture, before you even look at the picture, look at the trend for atomic size to determine if it's going to be interstitial or is it going to be substitutional, okay? And the same thing for metals. If we smash it and smash into small shape, this is what happened in this case. The stationary solid just shift, but the electrons are freely allowed to move. This allows to mold or hammer metals into any shape that we like, okay? Now let's look at another type of solid. This one right here is network covalent solid. Basically, these are atoms that are held together by covalent bond, which are very strong. But most importantly, right, because of the strong covalent bonds, network covalent solids have very high melting point and very high boiling point. And in some cases, it has higher melting point and boiling point than metals and ionic substance. For example, we have diamond right here. It has a very high melting point and boiling point. Another term when we talk about network covalent solid is that allotropes. So allotropes are basically different type of bonding form, okay? For example, right here we have graphite and we have diamond. Both are made of pure carbon, okay? But these two right here are two different forms of isotopes of the substance carbon. That's because they have different bonding structure, okay? So they have different bonding form. If we look at diamond, and if we look at this diamond right here, right, we have 1, 2, 3, 4. It's surrounded by 4 surrounding atoms. So therefore, it has a sp3 hybridized bond. Where if we look at graphite, it is surrounded by 3 surrounding atoms. In this case, it only shows you 2, but there's another one on top of it. So what we have is 1, 2, 3. So we have sp2 hybridized. And because of different bonding form, they have completely different chemical properties and physical properties. Now let's look at the last type of solid, which is molecular solid. We have ionic solid, which is resulting from what? Ionic compound, right? Or in this case, molecular solid resulting from molecular molecules, and that is molecule formed by covalent bonds. The key difference between molecular solid and network covalent is that in this case, network covalent are held together by covalent bond. That's why it's super strong. Where molecular solid are held together by intermolecular forces. Remember we talked about how molecule can be polar or nonpolar, but in that case, when they have that kind of partial charges, it's allow molecules to interact with each other and held together by intermolecular force, which is the force between molecules. Now let's look at a more specific example of molecular solid. Because the covalent molecules in a molecular solid are held together by intermolecular force, it has low melting point and boiling point. An example are ice, dry ice, and iodine crystals or polymers. Now we are going to look at polymer. Think of poly. Poly is a prefix for many, right? Well, polymer is a chain or a sequence consists of many monomers, and this monomer repeat itself. It form a long chain, and you already learned about this in your 9th grade biology class. It's polysaccharides. Polysaccharides is change of glucose. Now, to understand the term polymers, we can look at this example right here. We have ethylene, right? And what we have here, ethylene repeat itself, we can put together as a chain, okay? So we have polyethylene. So synthetic polymers are basically polymers that are produced in lab and in factories that we use in our daily life. So this concludes our discussion about different type of solid when we look at in terms of conductivity, in terms of melting point and boiling point, based on their intermolecular force and as well as intramolecular force, which is the force between atoms. Another word is chemical bond. And we'll see you next time on another exciting chemistry lesson.